Welcome everybody to the Future Leaders in Robotics and AI Celebrating Diversity and Innovation Seminar Series. This is part of the University of Maryland and Microsoft Robotics and Diversity Initiative and is sponsored by Microsoft DC Metro Engineering Site. This session is the first of this year, 2024. So we're really excited to get started. And I would like to remind everybody that you can find all of our talks online at robotics.umd.edu/futureleaders. So we're very lucky today. Our first speaker is Merihan Alhafnaw. Tongue-tied, sorry, apologies. Alhafnawi, opening night jitters. And Merihan is a postdoctoral research associate at Princeton University working on self-adaptive structures. She has a PhD in robotics and autonomous systems, which she earned in 2022, and a master's degree in robotics in 2019, both from the University of Bristol in the United Kingdom. She's received 2 Best Presentation Awards, one at the University of Bristol and one at the IROS workshop, and a Best Video Award at an ICRA workshop in 2021. These are for work on the MOSAIX swarm of 100 social robot tiles. Prior to her graduate studies and as part of the Digital Technology Leadership Program at General Electric, she supported projects such as Brilliant Factories, Digital Twins, and this was work done in the UAE, the UK, and the KSA. So prior to all of that, she obtained her bachelor's in science in computing and engineering from American University in Cairo back in 2016. Thank you very much for joining us, and please share your screen and take it away.
Great, thank you so much, Michael. Let me share my screen. All right, so thank you so much, everyone, for being here. It is my pleasure to kickstart the seminar series by introducing my research, which involves the design and build of expressive robot swarms that help people with social applications, so tasks from their everyday lives, using a swarm of robots. And robot swarms are actually inspired by natural swarms. So think of flocks of birds or schools of fish, swarms of ants and bees. And these natural swarms actually inspired robot swarm applications, such as sending a swarm of drones for forest firefighting, or a swarm of robots to manage warehouses, or even to explore outer space. But robot swarms are rarely used as to help people with social tasks. So imagine, for example, a group of people brainstorming ideas, or for example, networking events where people have to introduce themselves to other people they haven't met before, or even trying to come up with decisions. So robot swarms could really facilitate these group tasks. And in order to help facilitate these tasks, we have to add the human in the loop. So create human swarm interaction methods. But swarm systems are really decentralized. So there's no central controller telling each robot what to do. Instead, we have to figure out ways by which we add the human in the loop without breaking this decentralization, because this decentralization means that if one robot fails, the rest of the robots continue to work, and so the system is more robust. And so even adding multiple people is even a bigger challenge at this point, because we have to make sure that the multiple interactions that are happening simultaneously with the system does not break it. And so this has been really my research focus so far. So multi-human swarm interaction and building and designing expressive robot swarms that people could use to express themselves to and through. So really using robots as a new medium by which people could express themselves, especially to help them with social applications, with tasks from their daily lives. And a big part of my research actually is public engagement. And I think it's very important because we're building these systems for people to use at the end. So from people from the public. And having this dialogue between the public and researchers only serves to enhance the system, right? Because we then take into consideration what the people think of the system, what other uses they think actually might be useful for them, for the system, what applications they think is useful, and what they think of the design of the system. And so we could integrate this feedback into future iterations of design. And also, helps shortens the gap between what people think the state of the research of robots is, the state of the art versus what it really is. And so this dialogue is important. And so throughout my research journey, I have built three robotic systems. So the first one was Robotic Canvas, where a swarm of robots and a human could collaborate together to create art. And the second is MOSAIX, where I designed and built these 4-inch touch screen on wheels robots during my PhD to help with various social tasks. And the last one is Swarm Garden, where it's robotic elements that we've designed and built for shading mechanisms on facades, so to be put on buildings, but we've reimagined it as an artistic exhibition, a swarm of flowers. And I'm going to talk through these systems in details. So the first one is Robotic Canvas. And in Robotic Canvas, we're really reimagining robots as this painting material that you could use to create paintings. So I'm going to show you a performance that I did with the robot so you could understand how the system works. So first, sun sets on an ocean. Night arrives. Stars begin to show on the night sky. More stars begin to show. Clouds have formed as well. And then finally, the sun rises again. And so actually, I created 6 different painting modes in order to create paintings like these. So I'm going to mention them quickly, but first, you could use dedicated robots, or you could also use a projector that projects images on top of the robots. And so the robots recreate these images via their LEDs. So they sense it via their ambient light sensor and recreate it through their LEDs. Pixel eraser mode, which allows you to erase pixels by creating shadows on top of the robots. Palette coloring mode, which allows you to color the robots with different colors. So there are dedicated robots that send color information to the robots. Copy and paste mode, where you're able to copy and paste different parts of the canvas to other parts. And then finally, undo all mode, where you're able to use a dedicated robot to propagate a message to the swarm to tell it to go back to light painting mode, so as if, undoing the work that you've done. And finally, save all mode, where you can use robots called the memory robots to save and retrieve current paintings. And so with this work, you actually have to use or to fill the area entirely with robots in order to recreate an image. So the second bulk of work that I did with the kilobots is called salient section and representation. And by the way, these robots are small, 3.3 centimeter in diameter robots. They were created in Radhika Nakpal's lab in Harvard. They have an ambient light sensor and an LED. And so, instead of using it as a painting material, we've now used it as sculpting material. And this is by triggering the robots to send information about the color that they're sensing to their neighbors. And so every robot then combines the beliefs from its neighbors. And if it receives really conflicting opinions, then it stops. Otherwise, it moves randomly. And so now this actually, a new behavior emerges, which is edge detection, because the robots, if they receive conflicting opinions, that means that they're on an edge between 2 colors, and so you could create shapes that way as well. We've also used here we've tested the robots with up to 300 in real life, and with up to 1,000 in simulation, where we actually projected a GIF on top of the robot. So the robots are also able to create animations because they're able to adapt. And so this work with kilobots actually helped us a lot understand how people could express themselves and use the robots to send messages to the swarm, and use robots to create art. Also, how to exploit environmental interactions, such as creating shadows, etc., to send the robots a message. Distributed sensing and situational awareness. However, we still need to take the robots out of the lab to be used by the public in diverse applications. And so the kilobots are a great platform, but they are limited in terms of the feedback they give to the user. So we have only an LED and an ambient light sensor for input. And so during my PhD, I developed a new system called MOSAIX, and the individual robots are called tiles. So I designed and built 100 of these to create a swarm during my PhD. And they are 4-inch touchscreen robots on wheels that have 4 proximity sensors and a camera. the design is really a stack of components, so it's easy to mass manufacture and assemble. So here we have a custom-made PCB that hosts the 4 proximity sensors and the motors and the electronics, a power pack, a Raspberry Pi, and then on the top a touch screen, and all goes into a 3D printed case of our design as well. We've used the robots also in 4 different applications, and in these applications, more than 400 members of the public actually interacted with our robots, and some of these applications we've used up to 63 robots during the application. And so I'm going to talk about each application now. The first one is opinion mixing, where we took 32 robots out to a shopping mall, and we asked people to tell us their opinion about how they could decrease climate change. And so we showed the opinions on the screen, and then when they click on one of the opinion as a button, it's a button, it actually shows as a it shows on full screen, and then the robots then merge together, showing different opinions that people have entered. And so we thought that if people actually see other people's opinions, it could encourage them to actually voice their own opinion, and or at least have a dialogue among one another about like other people's opinions and what they themselves think. And so, you know, we were showing them the diversity of opinions of other people. And we actually created a focused user study. So here we have people holding the robots as if it's a tablet or a mobile phone, versus, you know, them actually entering the opinions and then the robots mixed together, just like the shopping center. And so we actually asked them, gave them a survey afterwards, and we asked them interacting with the robots was easy. And then here you can see the mean is about agree. And so for both conditions, we think the answers are more spread out and moving, just because some people told us in the feedback that if you have a disability and then bend over, it's going to be a bit hard. But then they agreed mostly that, you know, they were comfortable sharing the opinion using the robot. So that's great, because we wanted to make sure that the design of the robot does not hinder the interactivity of the system. And people actually felt more anonymous in the moving condition. And we were happy to see this, because we wanted to make sure that even if someone does not want to be associated with their opinion, they can still voice their opinion. So kind of increases the inclusivity. And then actually the number of interactions per participant increased in the moving condition. So we were happy to see this as well, because that means that, you know, people seeing other people's opinions and robots showing other people's opinions actually increased the number, or encouraged people to use the robots more and voice their opinion. And also the difference between their first and last opinions increased, which means they also changed their opinion more often in the moving condition. Which just shows also, again, that they're interacting more with the system and, you know, having dialogue with other people and reaching a decision at the end. We also used the robots as a collaborative art tool. So this was during the pandemic, where we couldn't, you know, bring people together. So we were brainstorming, how could we still bring people together even though they're remotely located? So we created a link, and we told people to enter on this website, and it gave them access to move robots around the arena and change the color of the screen. And the idea was to create collaborative art together. So every robot here that is moving, behind it is a person controlling it. And people actually came up with really interesting paintings. So for example, they made a palm tree and a football player, horses, or rather I should say soccer player, and horses, and a smiley face. And so not only did they create paintings together, but also really interesting interactions emerged. So for example, people started chasing each other around the arena, also trying to follow each other, knocking each other's robots off, which was a great durability test for the robots. So we were happy to bring people together, even though they weren't able to physically meet. We also used it as an educational tool. So we took 9 tiles out to teenage kids by showing the Mars Perseverance rover, and nursery kids by showing this cartoon character. And actually each robot acted as a moving jigsaw puzzle piece. So the idea was the robots were moving randomly, and we told the kids to try to figure out a way to stop it. So it was only by touch of a screen, and then the kids stopped the robots and then assembled the puzzle. And this actually gave us a great segue to have conversations with the kids. So for teenage kids, we took it as an opportunity to talk to them about STEM careers and robotic careers, and encourage them to consider pursuing these careers. but also we gave them the chance to ask about robotics in general, how to start learning about robots, what makes a robot, etc. And with nursery kids, we thought that it was still a great way to expose kids early on to robots and technology. And the last application that I did with the robots is brainstorming. So here we had a like, imagine in a corporate setting, for example, where you have a lot of people brainstorming ideas together. So you end up having so many Post-it notes that someone needs to sort them now in order to traverse through them. So if you use sticky Post-it notes, if you use the tiles as sticky Post-it notes, that would be great, because the tiles could then aggregate themselves autonomously based on different themes. And so it would be easier to traverse through ideas. And so there was a science museum at Bristol that was interested in adopting this tool. And so the museum said that they're interested in brainstorming with the public what the next exhibition should be about, especially concerning healthy lifestyles. So we asked people, what can the city of Bristol do to provide a healthier lifestyle for you? And so the idea that we hand them a robot that has a virtual keyboard, and then once they enter their idea, the robot just goes and finds its aggregate. So here's a video. The robots actually do have also a collision avoidance. So that's why when they collided, they avoided each other. And then the robots are now trying to go find their aggregate. So by the way, there are ideas on the robots, just the viewing angle and the lighting condition is not great from that angle, but it was the same as last slide where their ideas were showing. And so the robots then find their aggregate. We also asked people to actually enter the same opinion on a sticky Post-it note, a traditional one, and align it themselves, just so that they compare their ideas. And so we gave them a survey. We asked them how easy or hard was it to use the robotic system to enter ideas and traverse through them, and most of them agreed. And we were very happy to see this result. So by the way, this is first day, second day, third day, because we ran the experiment for 3 days, for 4 or 5 hours each day. And this is the result from all days. So most people agreed it was easy. They also thought that it would be helpful to use in brainstorming sessions. And they actually preferred, they thought the system performed better clusters when it's robotic versus traditional. And finally, overall, they preferred the robotic system. So we were happy to see that people still saw the benefit behind using robots as a brainstorming tool. And overall, they thought the robots were, from the feedback that they gave us, fun, engaging, and thought-provoking. And so the last part of my presentation is actually about my current work, which is adaptive and responsive swarm architecture. So it is in the intersection between architecture and robotic swarms. And the idea is we're trying to think of new methods by which we could have elements on facades that change shape and respond to the environment. And so our current work is actually a shading mechanism on facade. So imagine on a big window, instead of having a curtain, you could have a lot of modules stacked on top of each other and next to each other. And when they're flat, they don't allow light. But then when they buckle up, they allow light from the sides. And so you could actually control where the light comes in the room. And they could also adapt autonomously because they act in a swarm. So some can be closed and some can be opened. And this could be based on time of day, or what the human prefers. So a human could be like, oh, I want sunlight in this part of the room, but not the other part. It could also depend on the number of people present in the room or the amount of sunlight. And you could also then help control the temperature in the room as well. And flat sheets are great because they're easy to transport. So they're flat packed and they're easy to interchange. They're modular. So you could, if one fails, you could just exchange it with another. It's simple, 1 degree of freedom because it's only a pulling mechanism. And the simple geometry actually gives us the ability to predict the response of the system. And so actually, when you look at the module when it buckles, it kind of looks like a flower. And so, as I said, public engagement is important to me. And so we thought that as a first point of public engagement, we can create a swarm exhibition where people could interact with the robots as if they're flowers on like a wall of flowers. And so the robots could respond to people when as they walk by or as they create different gestures. And so we created 6 modules actually during my postdoc. That's what I've been busy doing. And I took 6 modules to IROS for people to interact with. That happened in Detroit in October. And shout out to Sabine Howard, who was my PhD advisor. However, I would like to actually invite you to an exhibition that we're creating at Princeton here, if you fancy driving to Princeton or flying to Princeton. It's going to be on April 9th, and we're going to have an entire wall of flowers. So about 36 to 40 modules where you could interact with them, and they're just going to look lively and pretty. So I really hope you can make it. And I'd like to end my presentation by reminding everyone that I work on multi-human swarm interaction. It's a new field and an emerging field. And I specifically am interested in looking at how how swarms could help groups of humans with social tasks. So whether it is brainstorming, collective art, decision-making, or even controlling the sunlight in your room. So thank you so much. And I'm happy to answer any questions.
Thank you, Merihan. You have only us people up here that are running it that you can hear chatting, but if clapping and chatting, if anybody would like to ask some questions, please put them in the question and answer box, and we'll make sure to ask those to Merihan. In the meantime, I have a question, which is when you're working with the people and they are making this collaborative art project, how did the humans that are interacting with the robots, any anecdotes about kind of how they collectively decided what image to work on, or did it not work like that, or any thoughts on that?
So actually, we had a Zoom session running, but not everybody joined the Zoom. So some people were on the Zoom and some people were just online, which was really interesting because like in the beginning, I was not sure if actually people are going to end up understanding what they're doing and if they're going to create collaborative art really. But then especially with the football player, with the soccer player, it was during the European Championship football league, something like that. So people had football a lot on their minds. And then someone on the chat was like, I'm just going to create a football player. And then suddenly everyone was like on board. And even the people that weren't on Zoom started understanding that, oh, we're creating a football player now. And it was really interesting to see.
That's very exciting. That's really cool. We have a question from Derek Paley, which is the following. Is it possible to equip the flowers with sensors to interact with people and or insects?
So actually the flowers currently, they have an ambient light sensor. Okay, so they actually have a board called Arduino NickleVision. It's a pretty new board. It's very small, and it has a camera, a proximity sensor, a microphone, and Bluetooth and Wi-Fi. So they're able to create still a network. And we actually, when we took it to IROS, we had we had a very simple interaction because it was early on in the prototype, where if people have their hand close to the robots, the flower kind of shies away from you. But if your hand is a little bit far, it comes closer to you. And so we're planning on having the camera and the proximity sensor as the main points of interaction with the people in the exhibition.
Great. I have another question, which is for the distributed art algorithm, the first thing that you showed. I really like the combo of art and robots. I think that's really amazing. And there were a few different things where it seems like the human is interacting directly, basically with one robot, but they're able to do it en masse. And then there was a few other algorithms where maybe the distributed communication ability of the robots came into play. Can you speak a little bit about which of the features that you enabled required the robots to use distributed sensing and communication and stuff like that?
Yeah, sure. So yeah, you're right. The different painting modes did have different techniques. So for example, light painting used the projector in order to just shine the image on the robots, and then they collectively create the robots, the image. For palette coloring, for example, we only had what we call a subswarm interaction, because you're only interacting with the part of the swarm that you want to color. So that just means that if the robots listen to, are within communication range with the robots that you can color with, that means that they'll just change their color. However, for example, copy paste is the most exciting one. I love it the most because it uses actually both of these interactions. So here, there's no camera telling the robots where the hand is. Instead, when you keep your hand over a robot for 5 seconds, it actually knows that, oh, we're in copy mode now. And it knows that because it senses a drop of ambient light that is caused by your hand. And then it actually talks to the robots around it and says, if you yourself detect a drop of ambient light, that means that the hand has moved over to you. And that's how the robots collectively keep track of where the hand is. There's no camera. Instead, they just have to depend on local and environmental interactions to do so.
Thank you. Question from Yancy Diaz. So have you seen any polarizing opinions or trolling behavior in the brainstorming or distributed painting application, as far as kind of wisdom of the crowd aspects go? Or mob mentality?
Yeah, that's true. So actually, it's very interesting because some opinions were very vague or not clear, and this confused the robots a little bit. So for example, I wouldn't say that was very vague, but someone wrote water taxi. And water taxi basically means that Bristol has this very beautiful harbor, and sometimes we want to take people from one place of the harbor to the other. So some people charge you for that. And so water taxi literally means just a boat that takes you from one place to the other. But then obviously, like, the robots were very confused and didn't know, okay, what do I do? There was already an aggregate that said what that had to do with water facilities, for example, like cleaner water or more water dispensers, and another that had to do with transportation, like more bikes, less cars in the city center. And so the robot instead went to the water facilities one. And so the person was like, oh no, I think it should have gone to transportation because it has to do more with transportation. And then when it went to the water facilities, it started pulling some transportation robots. And so you had these aggregates that were water/transportation, and another one that was just transportation. And so this kind of behavior can sometimes take another like an unexpected turn into the aggregates. And so I think a point of improvement on the system would be the robots actually learning from people. So someone would be like, no, you should have gone to transportation, and then that could enhance the algorithm.
Right. So there's time for maybe 2 quick questions. One is a high level question, and one is I don't know, different type of question. So one is, why use kilobots for the pixel canvas as compared to an LED matrix or some other sensor?
Sorry, why do I use the kilobots for what? Sorry.
Why use kilobots instead of, for example, just like a normal LED monitor?
Oh, right. So that's a good question. And I think part of why I created the robotic canvas was first of all to have this interactive new material that we could use for art. So reimagining robots as this new material that you can create art with, and also to understand how, as a human, we could create interactions with swarms, because it's not really very obvious how we could do that without breaking the decentralization. So it was a great point to start the research and also have an interesting application for it that people could understand, they could get their heads around, and also could use. And also when we did the focused user study with the tiles, we actually saw that people were much more interested in robots that are moving around and have the capability of being in the same environment as them, rather than just a mobile phone or a tablet. So that increased the interaction, which means that people use the system more. So we really think that having this physical system could be a point where people would be interested actually in adopting the system as well.
Great, that sounds good. We only have like 30 seconds left, so you probably can't do this following question justice, but how does one get into human-robot interaction and start on such interesting projects in the first place?
That's great. So the human swarm interaction specifically, there is a lot of like review papers, and this was literally how I started. So looking at what people have done before to kind of get into the inspiration of it. And also there are also many videos of how people actually interact with the robots, and believe it or not, that's been a huge inspiration to me, because then you understand what people are more interested in and what kind of interactions they find novel and interesting.
Well, thank you very much for joining us. Thank you for your wonderful talk and questions answered. Everybody, Merihan Alhafnaw, thank you very much for coming.